The Industrial Revolution changed how things were manufactured, and it's a period comprising from 1760 to sometime between 1820 and 1840. And this created a major disruption in the way that society worked and how we depended much more on the exploitation of energy, either chemical or electrical, and how we use that to replace human effort, and that's how we created mass production and how we were able to standardize products. And with that, we started to have different challenges in terms of manufacturing and distribution. With the Industrial Revolution, as I said, we enter a period in which the machines were more powerful, and we're using those for the mechanization of the production, for its mechanization of transportation, and with that we created inventories and standardized parts that were interchangeable, and that allowed for large quantities to be produced. That started to create those barriers, or the silos that each one were working for their own benefit before the different elements were put together into a single product. The barriers for integration, the second barrier for integration is a supply chain is a dynamic system that evolves with time, and that brings difficulty in reading what's really happening, because we not necessarily have visibility of all the elements that are, or the reasons for the system to change, and the capacities evolve with time, the demand evolves with time, and the backorders fluctuate even when demand does not fluctuate as much. That's a very interesting concept. In a simulation, we can prove that even when the demand, say for something that is not going to change in time, and this is how it was discovered, the consumption of diapers for babies. You know, babies consume diapers every day. They do not choose which days of the week they're gonna need diapers or not. However, because of the way that the distribution happens, the way that we schedule our promotions, and the way that we schedule the manufacturing facilities, it happens a phenomena that is very interesting, and it seems apparently the information that it flows from the demand centers, it is as if there were large amount of diapers to be consumed and then very few amounts of diapers to be consumed, which sends a very strange message to manufacturing, because now manufacturing needs to produce large amounts of diapers, and then there are periods in which they don't need as many. And the reason for that to happen, among other things, is, as I said, the delay of information. For instance, if the retailer sends the information to the wholesaler that they're going to need diapers, and they send information every other day, not every day, not as it's happening, but every other day, just that creates an accumulation of orders that says, well, one day we don't need diapers, and then the next day we need twice as many, as opposed to every day the same number of days, the same number of diapers. If the next step in the supply chain takes from the wholesale to manufacturer, let's say it takes 1 week, because the manufacturer will only distribute to the wholesaler a full load truck, and it's let's say 1 week of demand, then instead of having complete or instead of having just the order for that particular day, now it looks as if the demand were one day for the equivalent of 7 days, and not the equivalent for just one day and small deliveries. Of course, it's not cost efficient to have small deliveries, and that's why people group them. And then when we go to the manufacturing side, manufacturing decides to produce lots of, because, you know, especially with diapers nowadays, you have diapers for girls and for boys and different sizes. So they decide to go with runs, and I don't know what is the run right now, but let's say that for whatever reason it's 20 days or so, about 3 weeks. And now you have this signal that is a mixed signal that says, well, we want product every 2 days, combined with when we need the product every week. Now that's a lot of noise there, and then we add it every 3 weeks. And if you run that in a simulation, and you on average consume about 50 diapers per day, or 50 boxes of diapers per day, that would end up happening that you need an inventory of over 500 cases of diapers at the wholesaler, and over 2,000 cases of diapers in the manufacturer, which is just to cover the supply of that 50 diapers a day later on. Now imagine what happens when you have many stores, each one doing its own thing, and on top of that, promotion. So there are the system changing and giving this feedback. It is a very challenging quest. In order to understand what we're talking about here with systems behavior, I am going to recommend you to go ahead and look for this video on YouTube. The title is How Wolves Change Rivers. It's a very famous video, maybe you have seen it before. And well, I'm not trying to describe that the supply chain is necessarily these effects, and I'm not even trying to convey any idea about sustainability with this video. All I'm trying to do is to mention the complexity, how one element will change the next element, and that will change the next element in unpredictable ways, or very hard to predict. This works both for natural systems, ecosystems, as well as man-made systems, our social systems that we create either as societies, political parties, or in this case the supply chain. So go ahead. This video is that I'm suggesting is not very long. It's only 4 minutes and 33 seconds or so, and take notes, and if you have questions or comments, let me know. The videos that I am adding to the course might have copyrights, and that's why I cannot upload them into our course, and I appreciate you taking the time to explore them. They are selected for your benefit.